that usually or commonly targeting web applications: SQL injection and cross-site scripting, or XSS. Let's start by trying to explaining the first attack, SQL injection. We know that most of the modern dynamic web applications, they depend upon a back-end databases. So the front end, or the screens that will be demonstrated or displayed for the users or the customers for that specific website, they are going to be supported by a database server that fetch the data and display the appropriate data according to that specific user needs. And one example for the data that is going to be fetched from a database is the authentication process. For example, if you are trying to authenticate yourself to a certain website, let me just change this. If you are trying to authenticate yourself for a certain website, let's suppose this is you, the user, and you provided your credentials, your username and password. Those credentials will be passed to the front end, which is basically the screen of that specific web application. How the web application will know whether those credentials are correct or not? That is usually done by communicating with some sort of a repository. We call it the database server. And that repository is going to be queried, or we are going to simply ask a question for that specific repository to check. Well, do we have a user with that username? And if so, what is the password we store for that certain user? So in simple terms, we can say that we are asking that database server a simple question: what is the password for mChapel? After we receive the feedback from that repository, for example, the password received from that repository was, let's say, Apple, we will compare it against the password provided by that specific user. And usually this kind of transactions or this kind of inquiries is going to be carried using what we call structured query language, or SQL for short. SQL statements are basically a science. Some people, including myself, will study a complete course about how to write a proper SQL statements. But in this demonstration, I need you to know simple things about how SQL statements or SQL statements work. To be specific, in the previous example of database-driven authentication, you are going to send a query like this one, SQL statements like this one. Select username, password from user accounts where username equal username. This is basically a placeholder that will be replaced or populated by the value of the username provided by that specific user. This statement is going to simply get the value of the username, password from that specific table, user accounts, depending on the value of the username provided by that user. So if we go back to the same slide, we just said that we are going to inquire the database server. And we do that, as I just mentioned, by sending an SQL statement like this one. And this SQL statement is going to return the password stored for that specific user. If that password, of course, it will return the username and the password as well. But we are going to be more concerned about the password. And if the password is basically Apple, the same password provided by the user, in that case, we will know that this is a legit user and he is going to be authorized to access our website or web application whatsoever. So now, what is the relationship between this and SQL injection? Let's suppose I am a hacker, and instead of just passing my username in the field of username, I decided to pass this entire string. And before we will see the effect for that, I need to explain that semicolon in SQL statements means the end of a certain SQL command. So after this semicolon, the things after that is going to be treated as an independent or another SQL statement. This is one. The other thing is the double hyphens. This is basically used to write comments. So everything that is going to appear here is going to be treated as a comment. Comments are basically something that we write for yourself or for the people who are going to read your code, but it's not going to be executed. So, and let's see together what will be the effect of passing some input like this one as a username. All this value is going to be replaced or it's going to be inserted here, right? And the result of the SQL statement, assuming that we pass this strange string, is going to be this new string or this new SQL statement. Select username password from, let me just use the laser pointer, from user accounts where username equal mchapel, semicolon, update user accounts, set password equal hacked where username equal mchapel. What will happen here is going to be a bit interesting, by the way. You are going to select the username password from that specific table where the username is mchapel, and we don't really care about what are going to be those values. We are mostly interested in what will happen by the second part of the SQL statement, which is update user accounts. We are going to update the user accounts table. To do what? To set the password to this new password. So the value of that specific column password will be changed by this value hacked for that specific user where username equal mchapel. So by executing this statement, the password for that user, mchapel, is going to be changed to hacked, meaning I can try again to log in myself using mchapel as a username and hacked as a password. And since it has been already updated by this password, as a result of this SQL injection, I will be authorized. This is a very dangerous thing and it's very widely known. And to basically counter ourselves or ensure that we are capable of resisting uh, SQL injection attacks, we need to do what we call input validation or input sanitization. By that, we will check the input for these kind of dangerous characters, including semicolon, including single quotation, and make sure that they are not going to be used. And the other thing that we can use is to use what we call parameterized SQL. And this means the SQL statement is going to be pre-compiled. And by that, whenever we receive input, username or password, we are not really executing the SQL statement or compiling the SQL statement itself. We are simply using that pre-compiled SQL statement to do what it's supposed to do using this input. So the input, even if it was an SQL statement, is not going to be executed. Okay? And probably the most famous parameterized SQL approach is what we call the stored procedure. This is basically my presentation about the first part, the SQL injection. And now I would like to explore the cross-site scripting or XSS. Cross-site scripting occurs when an attacker embeds malicious scripts in a third-party website that are later run by innocent visitors to that site. So let's try to understand what that really means. First of all, usually we use HTML or hypertext markup language to enhance the appearance, formatting, and the use of images in our web applications or websites. And HTML works by the tags concept. For example, we can have a tag like B for bolding text, I for italics, and A for hyperlinks. And this is going to be a simple example to explain how the tags work in HTML. For example, if I want to add this URL as a hyperlink, I can use something like this one. And you can easily notice that we used the A tag for that. And it will appear like this. Whenever you click here, it will take you to that URL. Everything is absolutely fine, and it's a legit reason to use HTML tags. Another example is we have the script tag, and the script tag is going to allow you to write a code here, usually JavaScript code, that can be used for many legit reasons. For example, in this case, if I have one web page in my application that is currently under construction, I can send an alert using JavaScript by using the script tag. Okay, here I can write whatever code I like to write. And this is the dangerous thing about the input that can be provided by the user if the script is allowed. And I will provide an example for that. So cross-site scripting attackers embed scripts in sites without permission. And let's have an example for that. Assume that you have a website for auctions. So you are allowing the users of that website to write their own advertisements. And this is an example for an advertisement for someone who is trying to sell a boat. And obviously, in that advertisement, we have a couple of tags. It's going to make the advertisement a bit interesting. We have a picture, we have something bolded, and everything looks legit so far. But what if in the same advertisement, the advertiser basically used the script tag and inserted some malicious or evil code here? This code is going to be executed in the web browser of the visitors for that website, and accordingly, they are going to be compromised. The good thing is defending against the cross-site scripting attacks is kind of straightforward. We simply need to make sure that the user provided by the users, the people who are basically writing their advertisements, is not going to, they are not allowed to use a script tag. And after that, we will be safe against cross-site scripting attacks. This is my presentation, and I have one thing more to add or to do to include in this presentation, which is a Kahoot that I usually like to include in my classes. So, which language is used to communicate with relational databases? We all know the answer for that. It's SQL or structured query language. Let's check the other question. In SQL, what two dashes represent? It represents a comment, correct. And let's move forward. SQL injection targets databases used by web applications. This is true, right? Moving forward, which HTML tag is commonly abused in cross-site scripting attacks? We know that this is the script tag. And the last question is, the script tag cannot run programs in browsers. Actually, this is false. The dangerous element about the cross-site scripting attacks is the fact that the script tag can be executed or execute a code in the browsers of the visitors. That's it. I hope you enjoyed my presentation, and I'm looking forward to hear from you soon.